Here's part C of number 4 from the 2012 AB exam. First two pieces dealt with this function f, pretty standard. Take a derivative, find the equation of a tangent line at a certain value. And then in part C here, they define a new function. Let g be the function defined by this. So f of x is the definition for the function from -5 to -3. And then g of x is defined to be x plus 7 from -3 up to 5. It says, is g continuous at -3? Use the definition of continuity to explain your answer. So the definition of continuity is three pieces. Your function is continuous, and actually let me do it with regard to the function that we're trying to determine the continuity of here. G is continuous at -3 making this way harder than it should be right now. G is continuous at the x value of -3 if three things happen. First thing, g of -3 is defined. If your function's undefined at a certain location, you're not continuous there. We can put a check mark beside this real fast, because if you look at this inequality at the x value of -3, which is included on this top inequality, g of -3 is going to correspond to f of -3. So yep, that condition is met. The second condition is that the limit as x approaches -3 on the graph of g is going to exist. So does this exist? Well, this is going to be a little bit tricky here, because we have a split in how g is defined as we cross the value of -3. From the smaller side of -3, g is defined to be f of x. On the bigger side of -3, g is defined to be this line. So this is something that we're going to have to do some work to check. And then if that happens, if that gets a check mark beside it, then we're going to have to determine if g of -3 equals the limit as we approach -3 on the graph of g. So for this limit, I'll try to work this out over here. I said a minute ago that we're going to have to break this up into one-sided limits. On the smaller side of 3, this limit is going to correspond to f of -3. Right on the smaller side of -3, values on the smaller side of -3 would be within this interval. On the smaller side of -3, here's the definition of g. So to figure out what this limit is, we would just put -3 in place of that x, and f of -3, we actually found this in part B. If you put -3 there and simplify, what you end up with is you end up with a value of 4. Now if you check the limit as you approach -3 from the bigger side on the graph of g, that's going to correspond to using this definition for g with -3 put in place of that x. So -3 plus 7 is going to equal +4 still, because these one-sided limits are equal to each other. Yeah, we get a check mark beside that. G of the limit as we approach -3 on the graph of g of x does exist. The two one-sided limits equal each other. We had to be careful since we had a piecewise function broken up at the x value of -3. And then the last part, does the limit, now the limit as we approach -3, this value right here, that's equal to 4 based on the fact that these one-sided limits were the same. What's g of -3? Well, g of -3 equals f of -3, right? When you are at -3, this is the definition that you're using for g of x. So g of -3 equals f of -3 equals 4, which means, yep, check mark beside that. We satisfy all three pieces of the definition of continuity. G is definitely continuous at -3.